Chapter 7, Economic Growth by Professor Wagner. The outline of this chapter talks about the relatively recent arrival of economic growth, labor productivity, economic growth, components of economic growth, and economic convergence. This is an illustration of how many calories people consumed per day. And so it's been increasing, but it's also a direct correlation to the affordability based on working wages. We look at modern economic growth really going from 1870 onward, and that correlates with the advent of probably the second phase of the Industrial Revolution, where mass production and people working in factories became more of a regular situation than, let's say, previously, where America was more of an agrarian society. Rapid and sustained growth and a relatively recent experience in the human race. You can kind of take a look at, how things had evolved. If you go from, let's say, 1870 to 1910, what you've seen is the expansion of railroads, steamships, the airplane, the automobile, uh, electric light, the telephones. So really an enormous, technological advance occurred here in society, and that created, the new inventions, the new technology was a stimulus for very, strong economic growth. During the last 2 centuries, the average person's standard of living, uh, didn't really change all that much. So, whatever someone was, the typical standard of living for in the 1500s probably wasn't a great deal different in the 1700s. And so that's what they're speaking to there, and that's the pre-industrial age. Here, once again about the Industrial Revolution, you could take a look at the inequality amongst nations in 1870. It was about 2.4%, times the GDP per capita of the poorest economies. And then in 1960, that number rose to 4.2. There's a couple key factors that, impact the long-run economic growth: adherence to rule of law and protection of contractual rights. So we're really talking about things like patents, copyrights, defending, the rights to an inventor to his invention, and by law, and also agreements that businesses and individuals, or business to business, even more likely, the contractual agreements that occur between each other there. Labor growth and economic growth. Okay, labor productivity. So this is a measurement we speak about frequently, especially on the news, and it's something Wall Street watches a great deal, and they talk about, worker output, which is the productivity. There's an index they use, and over time, the productivity per person has gone up due to largely technological advances, not so much that people work so much faster or so much better than they did in the past, but technology is a strong leverage. Determinants of worker productivity, that's the human capital. So we have skills and expertise, and so there's a great deal of specialization in today's workforce. Technological change, invention and innovation, that this is really a constant. The only constant is change. Economies of scale, so there's cost advantages that industries obtain due to size. So you find these really huge conglomerates like Amazon, who really kind of control a great deal of shipping and distribution infrastructure in the United States. They have leveraged UPS and the Postal Service and FedEx for the longest time, and I think they continue to do so, but they're kind of gravitating away from that. And so that's because they have the economy of scale, and they find a way to do it better and cheaper and faster. You got the production function. So here You may want to take a look at that. A microeconomic production function is about the firm. It could also be about the industry's inputs and outputs. In macroeconomics, we talk about the connections of the inputs to outputs for the entire economy, or an aggregate production function. An aggregate production function is defined here below, and that's how the economy, as a whole turns inputs, such as all the factors, human capital, physical capital, technology, into some kind of output, and that's measured as GDP per capita. So you're going to want to remember the tie-in between aggregate production function and GDP per capita. Here is a pictorial of the components of aggregate production function, or we'll just go ahead and say APF. So you have the workforce, human capital, all this going into the GDP, and then the human capital per person, physical per person, technology per person is a per capita idea. So they're two different things. They're looking at aggregate production as a whole, as a nation, and then they look at the GDP, the aggregation per person, the output per person. And these are the comparatives used to see how, let's say, one country's doing as compared to another. An economy has a rate of productivity growth linked to the growth rate of its GDP per capita. And so the US productivity per worker is the dollar value output per hour that the worker contributes to the employer's output. And this measure excludes government workers and farming. Not government farming, but just farming in general and government workers. Okay, this is a graph that takes a look at the output, per hour in the U.S. economy. A lot of this is largely due to, this is an index. It starts somewhere here beneath 40, and here it's gone, to near present day, well above 100. So you can see that, much more labor has been produced. The power of sustained economic growth. Nothing is more important for the standard of living than sustained growth. Also, small changes in growth, when sustained, can make an enormous difference in the standard of living. And so there's a formula. Calculate GDP will be at any given growth rate per year. You have GDP at the starting date, 1 plus the rate of growth, times the number of years. This looks a lot like a financial, growth formula, but this, it's one and the same. Examples of GDP growth over different time horizons. So once again, they take a look at the growth rate and then what the index would look like at any given period. So at 25 years or 50 years, the original value begins at 100. Where would we be? So in 10 years, at 1%, we'd be here. At 8%, we would be here. So you can kind of see the exponential growth aspect. Compound growth rate, basically if South Korea had 1.67 trillion, had a growth rate of 2.8%, we could begin to estimate what the future GDP would be like. So here you have 1.76 trillion times this, which is 2.8 cents, 1 plus, and we just go ahead and turn that into a decimal, 0.028. And you do that, and you can do that for each year. You take this number here, carry it back over here, do the same function again, then you'll get a new number, and it keeps carrying on downward. There is a way to do this, a lot easier. I have a feeling the next slide's going to go ahead and show it. But basically, it would be 1.20 or 0.28. Once again, excuse my mouse here. You could take that to the 5th power times the original 1.67, and you would get this answer right here, 1.92 trillion. Components of economic growth. You have the physical capital, which includes factories, machines, equipment, and certainly the infrastructure surrounding that, the ability to distribute the goods after they're manufactured. So we're talking about rail and road systems and the increase in quality of all that. Human capital, the types of education and skills being acquired by the workforce in order to deal with the new technology and and really put themselves in a position where they're a lot more productive. Okay, a term capital deepening, probably would see this one on the test. It's when society increases the level of capital per person. And the idea of capital deepening can also apply to additional human capital per worker to additional physical capital per worker. So you might want to remember these two components for that definition. Okay, basically this is a graph of the capital deepening in the U.S. High school, number percentage who completed, 40% and 60. As opposed to 2010, you had nearly 90%. College, about 5%. Near currently, about 30%. So rising levels of education for the people 25 and older show the deepening capital of human capital in the U.S. economy. So 1/3 U.S. adults currently have completed a 4-year college degree, and certainly there's room for more growth, because people will require more specialized training even beyond the bachelor's degree. This is a graph showing the physical capital per worker in the United States. Okay, the rate of US dollars, real dollars per worker. So this is in terms of, physical capital, which is measured by plant and equipment used by the average worker in the U.S. economy, and that's risen over the decades. So in 1950, about 10,000 per worker, and that has grown to nearly 30,000 in 2010. You'll see by the graph that during the 70s and 80s, there were times of slower than usual growth. So you'll see a couple flat points in the graph here, let's say here. And then there was a flattening in the early 2000s, but you really can't see that. And so, this is really not a constant, but over time, it's a positive slope, and we've nearly tripled the amount of physical capital in a period of what looks like 60 years. There are growth accounting studies, so they're determining the extent to which fiscal and human capital deepening have contributed to growth. Technology is typically the most important component, and growth in human capital and physical capital only explains only half or less of the economic growth. So technology has become much more the leverage in terms of productivity, and amongst the three factors, which is human capital, physical, and technology. They all must be present to succeed. Emphasis on this one right here, though. Healthy climate for economic growth. Markets that promote rewards and incentives tend to increase human and physical capital, encourage over macroeconomic growth, meaning that if people feel like they're part of the process and it's inclusive and they get a slice of the pie, good examples are employee-owned businesses. They tend to do better per worker because they have a slice of what's going on. They have skin in the game, and people who have skin in the game have a lot more self-interest and are more inclined to help make the company succeed, as opposed to companies who view people as, let's just say, another asset like a machine or whatnot, and you're a number. And there are those companies, they tend to not do so well in terms of productivity. Areas with which governments around the world have chosen to invest, Note in deepening technology, education is here at the top. There's savings and investment, infrastructure, and special economic zones. So there are various things they'll tweak to try and promote growth. Economic convergence will be another term you might want to know. This is the pattern in which economies with low per capita incomes grow faster than economies with high per capita. High per capita income. So, high income, here's the growth rate, and during this period it was at that rate. Middle income, the growth rate went from 4.7 to this, and low income, has also gone up considerably too. So, middle income countries have a GDP growth that's faster than that of low income countries. And low income countries have GDP growth that is faster than high income countries as a result. Arguments favoring convergence. Low income countries have an advantage in achieving greater worker productivity and economic growth in the future. Diminishing marginal returns, could the lower income companies can converge to the levels of that of the high income countries. And then low income countries somewhere along the line might find it easier to improve their technologies than high income countries by applying technology that has already been invented. And there is even a term for this. They call it the advantages of backwardness. An economist, Gershon, he's come up with that. Low-income countries have observed the experience of those that have grown more quickly and learned from it. Probably we need to talk about some examples. So, in terms of per capita and income, China, since they use a great deal of forced labor and everything there, their income structure is really, well, they're just cheap labor. So, and they have technology, so the productivity could be quite high. They've got a GDP growth rate of 6-7%, or at least in the past they did. Currently, that's all changing on the base of trade relations, on the basis of what's going on with currently with the Corona crisis. So there's things impacting this, but typically that country, enjoyed a growth rate that was really a great deal more robust than what, let's say, a stable, established country like the United States would experience in the 2 to 3%, growth rate in GDP. India is another uppercomer, so they're another one of those low-income countries that have access to educated people and some technology. Their infrastructure isn't so great, but they're a player in this space just the same. Here are some of the arguments that convergence is neither inevitable or likely. So it's not empirical, it's not necessarily going to happen. So developing technology can provide a way for our economy to sidestep diminishing returns. And then will technological improvements run into diminishing returns over time? Doesn't really seem so. It seems like people are leveraging more technology all the time. So even the low income countries will begin to use similar technology. They just may use, let's say, the last generation technologies, which is still quite effective. Maybe not the most cutting edge. However, there is an extra efficiency added. Here we see a curve of 3 different technologies and how it impacts the growth per capita and the physical human capital numbers as well. So technology 1 has kind of a flatter curve. Technology 2, changes the trajectory of this curve. Technology 3. So there's no longer, with improvements in technology, there's really less reason that economic growth should necessarily slow down. This could be something on a test. I'd take a look at this example. and it's a problem demonstrating, the growth rates of convergence. So they have a high income country that has a GDP of capital 40,000 with a 2% growth rate after 30 years. It will have it'll have a GDP in 30 years of 72,450 per capita. How did he get that? Take 40,000, 2% interest rate, 1 plus 0.02, or you could just simply say 1.02 to the 30th power. That's a number of years, and that's how it comes up with the answer. Whereas a country that has 4,000 at GDP, but they have a 7% annual growth, will wind up with a GDP of 30,450. So you can see that where there's a 10 to 1 here between this country and that country, the gap has been closed by almost a half. End of chapter 7.